So today we're supposed to tackle Streamlit. But the reason I'm not going to start with it today is because today is on Wednesday. So I do want to start some portion of it, then on Monday proceed with the end-to-end data analysis project, because I want it to be conjoined, to be combined simply. That's the reason I'm going to tackle introduction to machine learning today. And another reason is because I have a bit of a flu, but yeah, I think we can cope with that. So yeah, so today we're going to tackle the introduction to machine learning. Then next week we'll tackle Streamlit, which simply Streamlit is a library that is in Python that is used for for creating interactive web apps. And you'll use Streamlit with a couple of other IDEs. You can use Visual Studio Code for the people who code maybe HTML, CSS, HTML, CSS, and JavaScript. Then you can also use the virtual IDE, which is Replit. Yeah, for our case, we won't use Visual Studio Code, VS Code. We'll use Replit since it doesn't need downloading. So yeah, that's just an overview of what we'll handle next week. And now we'll learn how to create projects, then send them as interactive web apps. So that is simply what Streamlit is. So today we're going to tackle machine learning, and I think this is not a buzzword to most of you people. I think you've heard the word machine learning, but maybe you never got the chance to dive deeper or dig in deeper into what machine learning is, and that is what we're going to do today. So from the table of contents, as you can see right here, is introduction to machine learning. So what is machine learning, the types of machine learning, the common application and use cases, which we'll have a look at. Then the data science framework for machine learning. Then the second thing will be problem definition. The third one will be data collection and preparation. Then exploratory data analysis, which is also known as EDA. Then the fifth one will be feature selection and engineering. The sixth section will be data splitting. Model selection will be the seventh one. Model validation, model testing, model deployment. Then the last step will be model monitoring and maintenance. So let me give you a heads up. There'll be a lot of buzzwords that you'll encounter while going through this slide, but don't worry about it. Since later on, we're going to dive deeper into the types of machine learning, and now we'll discuss those methods that you'll hear, maybe like the K-fold, the IQR, the detected outliers, such kind of things. Don't worry about them as per now, since as you can see here on our 22nd slide, it will be supervised learning regression. The other one will be supervised learning classification, which will combine both of them. Then the 24th and 25th will be unsupervised machine learning. So there's the third type of machine learning which we won't dive deep into, but we'll just have a simple outlook on what it is. So I think we're good till there. So the first question is, what is machine learning? So machine learning is a subset of artificial intelligence, or AI, that focuses on teaching computers to learn from data and improve over time without explicit programming. It uses algorithms to identify patterns and or make decisions or predictions based on the input data. The primary goal of machine learning is to enable computers to learn from experience and adapt to new information autonomously. So in this case, I think you've had an overview of what machine learning is, but to narrow it down is like in this case, let's use like this DeepMind game called AlphaGo. So that is machine learning, since you are training the computer to know how to play chess against the user. And in this case, it corrects itself through the reward and penalty method. But we'll have a look at it on a deeper scope, just a few slides from here. So I think you've known what machine learning is. It's simply teaching computers on how to do a certain task based off a subset of data that you've given it, or through progressive machine learning. So the types of machine learning, there are three types. So supervised learning, which we can see on our 22nd slide, we'll discuss. There's the supervised machine learning, the unsupervised machine learning, and there is reinforcement learning. So what is supervised machine learning? So the most common type of machine learning is supervised learning. That is the most common type of machine learning, and it is where the algorithm is trained on a labeled data set. What this means is you're giving the algo a picture of a cat and then labeling it down there that this is a cat. So that is what supervised machine learning is. You're giving it the input and the input label. I think that is a bit understandable. So there is the target and then there is the label. So the data set contains input-output pairs, where the output, also known as the label or target, is known for each input. Example. So the algorithm learns the mapping from inputs to outputs and aims to make accurate prediction for new uh, and unseen data. So examples of supervised learning tasks include regression, which we'll have a look at here. Supervised learning regression, which is simply predicting continuous values, and classification, which is predicting discrete categories, which we'll also dive deep on the 23rd slide. So that is simply supervised machine learning, whereby you give the algo that this is a cat, and then you tell it down there that this is a cat. This is a dog, then you tell it this is a dog. So you give it a lot of data with the labels, and then it will try to learn from that type of data. So that the next time it sees a cat, it identifies the pattern from the previous subset of data that you gave it, and try to see what is this. And it will now learn from that. That is what we call supervised machine learning. So unsupervised machine learning, the algorithm is trained on an unlabeled data set, meaning there are no known outputs or targets. So how this works is on the unsupervised machine learning, you'll just give it a picture of a cat. And then it will group these cats and find the patterns in how cats look. So it will see that they are whiskers. Are they called whiskers? I don't know. Yeah, something like that. So it will try to distinguish between the whiskers of a leopard or a lion from those of a cat. So you give it the data, but you don't give it labeled. So this is simply unsupervised. Since you're not telling it, this is that, this is this. That is simply unsupervised machine learning on surface level explanation. So the goal is to identify patterns or structures in the data, such as clusters, associations, or anomalies. That is simply what I was explaining. So it will try to identify how maybe the ears of a cat looks and how the ears of a leopard look. So it distinguish between both. So unsupervised learning tasks include clustering, grouping similar points, and dimensionality reduction, which is reducing the number of features while preserving important information. So there are some things that will be relevant when it's trying to find out which animal this is. So I'll still use the cat explanation. So in this case, dimensionality reduction works in the case where it won't account for the whiskers, since lions have whiskers. Leopards have whiskers, the cheetahs have whiskers. So it won't focus more on that, but it will focus on more of the distinguishable features between the both. I think you've understood what unsupervised machine learning is, which we'll also have a look at on our 24th and 25th slide on a deeper scope. Then the last type of machine learning is reinforcement learning. Just give me a minute. Yeah. So as I was saying, so the last form of machine learning is reinforcement machine learning. So this involves training an agent to make decisions based on interacting with an environment. So the agent receives feedbacks in the form of rewards or penalties and learns to make optimal decision based by maximizing the cumulative reward. So this is what I was saying when I was using the DeepMind. DeepMind is a subsection in Google's research program where they create different types of things. And there's this game called AlphaGo. So the method that they used to train this computer to know on what moves to make when playing chess, they used reinforcement learning, where it is simply based on rewards and penalties. As I had stated earlier, That is what reinforcement learning is. So this is, and actually, as much as we say that the unsupervised machine learning is not unsupervised, but the supervised machine learning is the most used. So in this evolving world that we are currently moving to, the tech world is evolving to this reinforcement learning. So companies like Figure AI, Unitree, Tesla, Zoox, those kind of companies are using this form of machine learning to train their models. So soon and soon enough, this will be the main used form of machine learning. So common applications and use cases. So image and speech recognition. So identifying objects in images and transcribing spoken words into text. I think these you can use either of the machine learning methods, either the supervised or unsupervised. Yeah, depends. Then there's NLP, which is also natural language processing. So in this case, it's sentiment analysis, language translation, and text summarization. So in this case, things like this GPT. I'm sorry. Can I do a quick recap of uh, of the whole thing? Okay, what I'll do is that you're not left out. Instead of recapping the whole thing, I'll just draft a summary, which I think will be easier for most of you, because as I had said, there'll be a lot of buzzwords that will be quite confusing when we scroll down. So what I'll do is I'll give you guys I'll draft up a PDF summary that will contain easier understanding of all these types of machine learning and simply machine learning as a unit and all the frameworks involved. I think that is the best way, since when we start again, it will be a bit of an inconvenience for everybody, unless you all stand with that opinion. So I'll just draft something simple, something that it will be so easy for you guys to read. Since even on your free time when you're trying to read this curriculum, I think it will be a bit tough for you guys. But yeah, if you can, the better. But if you can't, I'll draft up a summary. I hope that's good, Benedict. But simply I've stated that there are three forms of machine learning: the supervised, unsupervised, and reinforcement. Uh, whereby I've said supervised is where you give it the picture of a cat and telling it this is a cat. That is simply supervised machine learning. Then unsupervised is whereby you're giving it pictures of cats and it is trying to detect the common patterns in the cats. That is unsupervised machine learning. Then reinforcement learning is whereby it makes decisions based off interacting with an environment. So we've said it makes decisions based off rewards and penalties. So let's continue with the common application and use cases of machine learning. And I was explaining the NLP, whereby I said in the form of like the GPT, ChatGPT, this that is one case of machine learning, since it can do sentiment analysis, it can do text summarization, it can do language translation. Yeah, that is simply NLPs, which we'll also discuss more um later on. So recommender system. So recommender system is in the case like Netflix. Netflix, when you watch one category of a show, it recommends something similar. So what it does, it identifies the patterns that the user is watching. So let us assume you're watching a lot of which case? Thriller movies or action movies. So it will detect the patterns that this user mostly comes to our platform and watches this kind of movie. So it will suggest similar movies to the ones that it has detected that you are more interested into. So that is simply recommender systems. That is machine learning. That is the third form of machine learning, which is reinforcement. Then fraud detection, which is identifying fraudulent activities based off patterns. How frequent did you try putting in your PIN? How frequent did you try setting this amount? That is simply fraud detection using machine learning to identify the patterns of maybe the number of trials of pins. Since in some platforms, when you input a wrong pin maybe two, three times, it will flag you and tell you we want to verify it's you. So another case of machine learning. The other one is healthcare. So in this healthcare, they use it to detect when the patient is supposed to be discharged. That is one use case of healthcare. Then on the finance, it's creating bots for analyzing markets. So for the ones that have been into trading, there are people who create trading bots, and then it checks the patterns that have been there in the charts and comes up with the next point that is supposed to be hit, the next target point. So if it checks that after this number of candlesticks, this was the outcome, after this type of a pattern, this was the outcome, it will predict based off previous data. So that's on the finance. Then on the autonomous system, which in this case, it's self-driving cars, robotics, and smart home automation. So I think let me show you guys like a company that does car automation, which is Zoox. Maybe some of you have heard of Zoox. So as we all know, place like the San Francisco is the hub of technology, right? So when you try and check out how these people work, you'll see that this is they are living in the future. Simply, California is quite different from every other state since you'll find people being driven by this kind of cars, and it has become something that is so common. So you can see this. This is the model that they've created, and you know there are different levels of automation. There is the we're not yet there on the fully automation as the grading system says, but companies like Zoox are almost there. See, where they use radars, they use sensors, they use cameras to maintain some things. Maybe some of you, let's exclude the automation, the car automation, but maybe some of you have seen a feature in cars like cruise control. Cruise control is also one form of self-driving, since you'll just set the parameters, then you're good to go. So companies like Zoox are almost there. So in the next couple of years, driving will be something different. So yeah, I think you guys will have a look at it maybe later on. This is a Cali company. I'm not sure if it's an SF company, but it is from Cali. And you guys know about Tesla. Yeah. So those are the companies that mainly major in the car automation industry, as to my knowledge. Whereby other companies like Xiaomi, the company that creates phones, it also creates autonomous cars. Maybe on your free time you can go and have a look at it. It's a pretty interesting field and concept to understand. So on the robotics, I don't know if you guys know Unitree. It's a Chinese company that creates robots. Their main specialization was the dog-looking robots. I don't know if you guys know a company called Boston Dynamics, but Boston Dynamics are slept on their work now. Companies like Unity are coming to overtake them because I knew Boston Dynamics like so many years ago, but they are still on the same concept. Whereby companies like Unity came, conquered, and now are moving to the next thing. So the tech market is evolving so fast. So companies like Unity are creating robots. And I don't know if you know the event that was there. Can't remember what was the name of it, where they were launching different innovations, the new innovations, where NVIDIA displayed their new GX processors. Yeah, so a company like Unity, uh, it does those minor tasks like maybe doing your laundry, like what is yet to be done by these robotic companies is things like cooking. Since it's a very huge machine, and we're trying to make it compact so that maybe later on in the next like 10 years you are buying a robot and it's doing the cooking, it's doing the laundry, it's doing the cleaning. Yeah. So companies like Unitree and another company called Figure AI. So this is another company that ventures into robotics. Yeah, they are doing something quite nice since you can see it has a certain workload. I don't know if it's here. They've stated it. Yeah, payload. So this is the amount of kilos it can carry, which is quite fascinating as we know that the humanoids are not really capable of that. So you see the weight is quite good, 70 kgs. The runtime is 5 hours. So as soon as you charge it, it's giving you 5 hours of service. Then the speed is 1.2 meters per second, and the system is electric. So yeah, you guys can have a look at it maybe on your free time. And yeah. So the next thing we're going to talk about is data science frameworks for machine learning. So a data science framework for machine learning is a structured approach that provides guidance throughout the process of building, deploying, and maintaining machine learning models. The framework consists of several key steps, which are designed to help data scientists and machine learning engineers organize their work and ensure that they follow the best practice. And we'll have a look at those best practices on how you do clean the data, how you explore the data, how you analyze the data. Yeah, we'll have a look at it just a couple of slides from here. So this is the introduction to the data science framework for machine learning. So the first thing is problem definition. So clearly identify the problem you want to solve, the goals and the objectives of the project, and the type of machine learning task. So in this case, it's classification, regression, and clustering, which we'll later on have a look at on the supervised learning, regression, and supervised learning classification. So understanding the problem is the first step. So the next thing is data collection and preparation. So you can collect data from like web scraping, from APIs. So this company, I don't know if you guys know about API. I don't know, API. So this company simply, you give it the website that you want to scrape up data from, and it creates an API. So an API gives you the data based off the website that you have specified. So tools like this are really making the tech industry to be so easy. And as much as we are afraid that AI is coming to replace us, I'm a bit skeptical about it, but I don't want to be in denial. It's doing a really amazing job. So I think John told you about a company called Bolt, where it's on the verge of replacing the front end web developers, since it's doing a really awesome job on creating very good UIs, but they're a bit behind in creating UIs. There's also the Replit AI agent where it also creates websites automatically. You just give it the prompts and it does everything on its own. But the problem with this kind of agents is that it's hard replacing these people because they're the same people who are supposed to update the websites, the data. They're the same people who are supposed to update it. And another moment I love to reference back is something that happened last year. I don't know, it was on June. I usually refer it to as the Devin moment, since it was a bit of it was a bit of a scare for me because Devin was hyped at that time on it will replace these tech people because then on because back then the prototype that they had shown the people was really amazing, but when they came to the final product was not really fascinating, but it was fascinating. But yeah, all I can tell you guys is yes, AI will maybe replace us, but not anytime soon. But you must take advantage of it just view it as a good thing since it is here to help. Something like ChatGPT, instead of writing codes from scratch, you just go and prompt it and it gives you the desired outputs. So yeah, so data collection and preparation. So you gather required data from various sources such as databases, which we have already tackled, APIs. So companies provide APIs. Then the other one is web scraping. So that is data collection and preparation. So clean and pre-process the data by handling missing values, outliers, which we'll have a look at IQR, which simply means interquartile range, and inconsistencies, and transform the data into a suitable format for machine learning algorithms. Just a minute. Then the next step is EDA, which simply means exploratory data analysis. So analyze the data using descriptive analysis and visualization techniques to gain insights. So on yesterday's assignment, I remember there was a question about generating insights, but I labeled it as optional since wanted it to do I wanted first to show you guys how you generate the insights from it, which I don't think we've done. So on the next end-to-end, so next week on Tuesday, most likely, when we tackle the end-to-end data analysis projects, I'll show you guys on generating insights and yeah, such kind of thing. So that is can you guys hear me perfectly? Okay. I don't know if it's my network or can the rest confirm if I'm breaking? So Canelo has confirmed he's hearing me quite perfectly. So
I think the problem is with Benedict.
I'm sorry.
I think the disconnect is from Benedict's side, but we can hear you clearly. But he's giving a thumbs up now.
Oh, okay. Thank you for the feedback. So yeah, we'll proceed from the where we've left off. So I was explaining EDA, exploratory data analysis, and as I was saying, we'll cover this more on next not next session, but next week on Tuesday when we tackle the end-to-end data analysis project. So the other step is feature selection and engineering. So select the most important feature that contributes to the predictive power of the model and engineer new features or transform existing ones to improve model performance. So this step is quite crucial for reducing the model complexity. So this feature selection and engineering. So the way I can explain it better is first, the breakthrough moment for like a company like ChatGPT was, I think it was ChatGPT 3.5, version 3.5. So the way that they reduce the model complexity is what we call feature selection and engineering. So they optimize more on maybe how the threads are used on the GPUs, yeah, such kind of things. So that is feature selection and engineering. So and right now you can see there are a couple of models like the O3, O3 Mini, the O1, O1 Mini, and now the plain 4O, which I've had the chance to use on the O3 Mini, and yeah, it's doing quite an amazing job on like coding. It's doing a really good job, but to my preference, as much as it's hyped, I prefer the O1 since O3 is the price that they have capped it is quite quite high. So yeah, one is quite good. So the next thing is data splitting. So split the data set into training, validation, and testing sets to ensure that the model can be trained, fine-tuned, and evaluated on separate portions of the data. This process helps prevent overfitting and provides an unbiased estimate on the model's performance. So what simply data splitting entails, so at times you'd find companies so when people were bringing out companies to VCs like Anderson Horowitz, Y Combinator. So when they were analyzing it, there was this company I was looking at. So they were saying that it's a company masked under ChatGPT. So I wasn't really satisfied with the response of the VC since some companies fine tune data, and that is simply data splitting. So fine tuning is yes, I'll get data from ChatGPT, but I've gone on an extra step on validating and training my own model, but based off data from ChatGPT. So maybe I'll be like a healthcare model. So I'll just take the data from ChatGPT since I don't have the money to train models right from scratch, since it will be a bit expensive. So, but I don't know if you guys heard about the deep seek moment whereby they cut costs of trading the models from like, was it, I don't know if ChatGPT trained trained the models using $120 million. So DeepSeek trained the models using $5 million, which was quite fascinating. So ChatGPT was stating facts like DeepSeek was using their data, and it created some chaos on the Twitter platform, and which I supported DeepSeek because GPT, as much as they say they own the data, they are fishing data from other companies. They are buying data from other companies. So companies like DeepSeek are using this method of data splitting where they fetch data from other companies, then they fine tune their data and make it even better. So back to my example where I was using a healthcare. So I might create a healthcare form of a GPT, but it has specialized on healthcare only, whereby if you ask it maybe what kind of a disease this is, it gives you the detailed explanation whereby in ChatGPT, if you don't have the knowledge of that disease, it will just give you an overview. It will just tell you this is this and these are the symptoms. But when you fine tune your data, it gives a bigger image of what the user wants. So that is simply data splitting. So model selection and training. So choose an appropriate machine learning algorithm based on the problem type and data set, and train the model using the training data. This step may involve trying multiple algorithms and comparing their performance to select the best one. I think that is self-explanatory. So the other one is model validation and tuning, which we have already seen here on data splitting. Evaluate the model's performance on the validation set using appropriate metrics, and we'll see on the appropriate metrics that you're supposed to use when trying to validate the performance of a model. And fine-tune hyperparameters or other model components to improve its performance. And once again, I've explained it using the DeepSeek explanation. So this step helps ensure that the model is well-tuned and optimized for the specific problem and data set. But all these we'll have a look at them deeper right after this. So the other one is model testing and evaluation. Access the final model's performance on the tests set, which provides an unbiased estimate of how well the model is likely to perform on unseen data. Interpret the results and draw conclusions about the model's effectiveness and applicability to the problem. So model testing. So on this case, I don't know if you guys have heard of the company Lechart, which is you prior to this year, the EU had very funny restrictions on AI models, but this year they came with a banger called Mistral was existing, but it was under and it was laying low. So Mistral came up with a new AI. Maybe you guys can try it out and give it a try. So it's called Lechart. So Lechart, so this company, you can have a look at it. It's a very good, it's doing a really good job. So compared to ChatGPT and other companies like is it Kiwi or Kiwi? Kiwi. Kiwi, if I'm not wrong. Is it Kiwi? Can't remember the name. But yeah, it's and it's coined by Alibaba, OpenAI. Yeah, you guys can try all these AIs and maybe you'll give me the best one from your opinion. Yeah. So model testing and evaluation. So as I was saying, on the model testing case, a company like Lechart, which I've shown you guys, they were not most companies tend to fool themselves on the model testing phase, whereby they don't want to give their to test their models fully. So company like Lechart did that job really well. Yeah. So the other point is model deployment. So deploy the trained model to a production environment such as cloud platform or API, and integrate it with web applications, mobile apps, or other systems to provide real world value. So another thing we'll have a look at next week on the Streamlit. So you'll get to see how you deploy these kinds of things like the models in a form of web app. And now the last section is model monitoring and maintenance. So continuously monitor the model's performance in production, update it with new data, and retrain it as needed to maintain its accuracy and relevance. So this is the case of getting from GPT 3.5 to GPT-4 to GPT-4o to GPT-4o1, one mini or three, so on and so forth. So the different models, this is simply model monitoring and maintenance, since you are updating it with new data and retraining it. Yeah. So now on this first step of product problem definition, so we'll have a look at it here. So there are three identifying problem methods. So it's the first one is regression, there's classification, there's clustering, and there's other methods like reinforcement learning tasks, the series analysis, the reduction, dimensionality reduction, which we've already seen up there. So regression is simply predicting a continuous target variable based on input features. So examples include house price prediction, sales forecasting, and stock market prediction. So in this case, like price prediction, a company like Zillow, it's a real estate company. It uses regression to predict on how much property will cost maybe in the next 2 years, in the next 5 years. It takes the labels like rates, current rates, then predicts the future on how the price will vary in the next couple of years. So maybe if we have a look at property, maybe in place like San Francisco. So for this one bedroom apartment, the price is $361,000. So when it uses the regression method of predicting the prices, it will maybe state in the next like 5 to 10 years, the value of this apartment will have skyrocketed maybe to like $500,000 to like $1 million, depending on the location. So it uses a couple of input data sets to predict the prices, but based off regression. So yeah. The next method is classification, which it predicts a categorical target variable based off input features. So this is simply like identifying patterns, then putting them into a certain category. So examples include spam detection. So in this case, maybe you're sending bulk messages. So when you send bulk messages, uh, I don't know which software bans you from sending bulk messages, but let's say WhatsApp. So how they use classification as a method of identifying the problem is that they'll see the pattern in you sending the messages. If you've not paid for the feature of bulk sending bulk SMSs, and maybe one person reports you, that is it will categorize that the type of a text of that person as a fraud. So it will completely ban you. So that is classification. Clustering is grouping similar data points together based off their feature without a specific target variable. So examples include customer segmentation, anomaly detection, and document clustering. So when it detects anomalies in certain data, it groups it into one cluster, and that is what we call clustering. Other problems, other problem types include dimensionality reduction, time series analysis, and reinforcement learning tasks. So defining project goals and objectives. So clearly outline the problem you aim to solve and desired outcome. It's, so specify the scope and limitations of the project, identify stakeholders and their requirements, then establish a timeline for the project, including milestones and deliverables. And the last one is determining the resources needed, such as data, tools, and team members. I think that is quite self-explanatory. Yeah. So selecting evaluation metrics, which we had seen up here. Mm, self-evaluation. Yeah. simply had stated that we will have a look at the ROC, MAE. So selecting evaluation metrics is important on how to gauge the performance of your ML model. So choose appropriate metrics to measure the performance of your machine learning model. So regression metrics, which in this case is mean absolute error. Then there is the mean squared error, root mean squared error, R squared, etc. And the classification metrics is accuracy, precision, recall, F1 score, ROC, so area under the receiver operating characteristics. The last one is clustering metrics. So in this case, it's Silhouette score, Kalinski-Harvard Maths index, and David's Boulding index. I told you guys that you'll find a lot of buzzwords, but let this not worry you, since we'll later on discuss more deeply on how you select this metric based off this type of a situation. These are the metric based off this type of situation. Yeah. So the next one is data collection and preparation. Is there any question so far? Or I think we're good. Okay, so I think I'm proceed. So data sources. So databases, relational databases, which we had that look at, which is SQL, then and the NoSQL databases, which in this case is databases like MongoDB. That is one data source, which in this case is databases, the SQL and then no SQL databases. Then there is APIs, and we have looked at a company that web scrapes website then gives you APIs, but other developers also create APIs for their platform. So yeah, APIs is another form of fetching data or getting data. Then the other one is web scraping, extracting data from websites using tools like Beautify, Scoop, Scrapy, and Selenium. That is web scraping. And another method is also web scraping and converting into APIs. Then there's open data repositories, which in this case we had a look at Kaggle. So where most data scientists put in their data. So that is one point of getting your data source. I think you guys remember Kaggle. Then the last one is surveys, experiments, and IoT devices. So this is simply getting reviews from the users. That is another form, another place where you can get your data. So there is data cleaning. So there is handling missing values. So techniques of handling missing values. The most common one is like the KNN, which is the K nearest neighbor, and we'll also have a look at it in the next week's session, or regression imputation. So impute missing values using methods like mean or median imputation, forward or backward filling, or more advanced techniques like KNN, which is K next neighbor, K nearest neighbor, not next, K nearest neighbor, or regression inputs. Alternatively, remove rows or columns with missing values if appropriate. So we had a look on how to eliminate certain values in a row without deleting the whole row. So that's a method of handling missing values, which is not preferred, but yeah, which some people use. Then the other one is detecting outliers, and one method of detecting outliers is using the Z-score or the IQR, which is the interquartile range. From these two, I prefer the IQR one, but some data scientists like to identify outliers using the Z-score method. Tricky fences, not really. So consider whether to remove, transform, or keep outliers based on domain knowledge and the specific problem. So most of the time you won't remove the outliers. So you'll use the outliers to detect maybe abnormalities in certain data sets. The other one is, sorry about that. The other one is inconsistencies. Address issues such as duplicate records, incorrect data types, or inconsistent formatting, which you also had a look at when you were tackling pandas. So data preprocessing, normalization. So scale numeric features to a common range, 0 to 1, using methods like min-max scaling, especially for algorithms sensitive to feature scales like the KNN, which I've stated we'll have a look at it. So you'll see that it's sensitive to feature scales and or support vector machines. The other one is standardization. So scale numeric features to have a mean of 0 and a standard deviation of 1. So we had a look at how you look for standard deviations using pandas. So using methods like Z-score standardization, this is useful for algorithms that assume features have Gaussian distribution, such as linear regression, which we'll have a look at on the supervised learning regression. Then the other step is encoding, convert categorical data into a numerical format using techniques like one-hot encoding, label encoding, or target encoding, which we have had a look at targets and label encoding, which is simply giving it a picture and giving that label or a target. Then the other one is feature transformations. Apply transformations like log, square root, or power to features to address skewness or non-linearity. Then the last step of data pre-processing is handling imbalanced data. Use techniques like oversampling, undersampling, or generating synthetic samples using SMOT to balance the class distribution in classification tasks. So you'll mainly use this method of classifying them in classes when you're using the classification method. Just a minute. I can see you want the GitHub link to the class. Well, let me paste it. Let me paste it directly. Class from the Actually, I think we're good till there. Yeah, so that's the link on the chart. So you'll access the link to the slides that I'm reading to the curriculum simply. So I was on the EDA, which is exploratory data analysis. So descriptive analysis, which in this case is finding the mean, the median, the mode, the variance, standard deviation, IQR, which you can use it to check outliers, and the skewness, which measures the data shape distribution of the data. So I think there's not much to state on the descriptive statistics since we have already covered that. Then on the data visualization, these two, we've already checked the histograms, the different types of plots when you're data visualizing. So histograms, scatter plots, bar plots, box plots, heat maps, pair plots. I think these two are the only ones that we have not discussed. But on heat maps, when we're discussing correlation, we'll have a look at it. Then pair plots, we will have a look at it too, but not on a deep scale. So identifying patterns, trends, and relationships in data. So the first one is correlation. So measure the strength and direction of linear relationship between pairs of continuous variables. You can use scatter plots to get the relationship between different variables. So positive correlation indicates that variables increase together, while negative correlation indicates that one variable increases as the other decreases. So you can represent a correlation using the heat maps, which we'll have a look at. Then outliers. Identify unusual observations that may warrant further investigation or require special handling in the modeling process. So outliers sometimes you that's the reason I said that you don't eliminate outliers is when you like try to get things like churn prediction or behaviors of maybe a customer, you use maybe some outliers, not all, but some. So trends, observe trends or patterns in the data such as seasonality, cyclical patterns, or increasing slash decreasing trends over time. Then the last one is feature interactions. Investigate the relationships between features and the target variable, as well as interactions between pairs features. So EDA is a essential step in the machine learning process as it helps you to gain a deeper understanding of the data, uncover insights, and make informed decisions about feature selection and engineering, model selections, and other aspects of the project. So feature selection and engineering. So feature importance and selection methods. So we've had a look at correlation, which is simply measuring the linear relationship between maybe two or more variables and identifying the relevant features between the two. So keep in mind that correlation does not imply causation and may not capture non-linear relationships. So there is mutual information. Quantify the dependency between each figure and the target variable, capturing both linear and nonlinear relationships. Higher mutual information values indicate stronger relationships between the feature and the target. Then there's RFE, which is recursive feature elimination, an iterative method that eliminates the least important features one by one based on their importance from a model, which in this case we have stated a thing like eliminating things like whiskers when you are using the supervised learning or unsupervised machine learning. So you use RFE to eliminate things like when you're trying to distinguish cat from leopard. So you eliminate things like maybe whiskers, but you won't completely eliminate it when you think of it, since you'll maybe tend to look at the size of the whiskers. But yeah, so that's RFE. Then regularization measure, regular, legu, regular, regularization methods. I'm having a challenge stating that. Lasso, ridge, and elastic net are one of are examples of the regularization methods. Apply regularization techniques during model training to automatically select important features and reduce overfitting. And then the last one is feature importance from tree-based models. Use importance scores for models like decision trees, random forest, or gradient boosting machines to rank features. So these are types of tree-based models. So we'll have a look at decision trees, random forest, but on the gradient boosting machines, when you're ranking features, we won't use that. So feature engineering techniques. So there's transformations, aggregations, interaction features, time-based features, and text features. So transformations apply mathematical functions to feature such as log, square root, or power to address skewness, non-linearity, or improve model performance. I think we had a look at that. Then aggregations. So create aggregated features using summary statistics, mean, median, sum, of a group of related data points, which you also had a look at. Then interaction features generate new features by combining or multiplying existing features, capturing interactions between them. So, which we also had a look at. Most of these things we had a look at them when we were discussing pandas and numpys. So, price per foot square is equals to price per area. That is the example given with the interaction features. Then time-based features. Extract time-based features from date and time, such as day of the week, month, or time, since a specific event. And I think we had a look at how you extract these kinds of data, like the time from a given CSV maybe or an XML file. But when we are looking at the end-to-end data analysis project, so we'll have a look at these two. All these things will also recap them when we are doing the end-to-end data analysis projects. So the other feature engineering technique is text features. Process text data to create sorry about that. Process text data to create features like word count, term frequency, inverse document frequency, which is TF or EF, or embeddings. So things like word count, I think you've interacted with them. Then there's dimensionality reduction, which is a bit tricky. So there's the PCA, which is principal component analysis, a linear transformation technique that projects high dimensional data onto a lower dimensional subspace, retaining the most significant variation in the data. This is quite massive, but we'll explain it simpler when we get there. Then T distributed stochastic neighbor embedding, which is TSNE, a nonlinear dimensionality reduction method that preserves the local structure of data, often used for visualization purposes. And this LDA, which is linear discriminant analysis, a supervised dimensionality reduction technique that maximizes the separation between classes. And there's the autoencoders, which is used for dimensionality reduction. So a type of neural network, that's another new one, which we'll have a look at when we get to the convolution of neural networks. So a type of neural network that learns a lower dimensional representation of the input data by encoding and then reconstructing it. Once again, we'll have a look at autoencoders when we get to neural networks. So the next one is data splitting. So in this case, there are a couple of data splitting methods which we have stated right here. Train, test, split, cross-validation, which in cross-validation, there are a couple of methods like the k-fold cross-validation. So on train, test, split, a technique to divide the data set into two separate subsets, a training set and a testing set. So you divide the sets into two cases. So there's the training set and the testing set. The training set is used to train the machine learning model, while the testing set is used to evaluate the model's performance on unseen data. So common split ratios of these subsets include the 70 to 30% ratio. So 70% is training set, then 30% is testing set. So the common split ratios are 70-30, 80-20, 90-10, depending on the size and nature of the subset. So it's essential to ensure that the split is random and the data is representative of the entire data set to avoid introduction bias into the model evaluation. So the reason of making the split random is when you're testing your model, you don't want to favor it more. You want to put it to the max limits. You want it to test it fully. So you split the data randomly. So there's the validation. So a more robust method for accessing model performance that reduces the risk of fitting and providing a better estimate of the model's generalization ability. So in this case, there is the k-fold cross-validation, and there's the stratified k-fold cross-validation, which is also similar to the k-fold validation. So the k-fold validation is a data set that is divided into k equally sized fold. The model is trained a k number of times, which is a variable. Each time using k1 folds as the training set and the remaining fold as the validation set. The final model performance is calculating when the average performance across all k iterations. So simply all k1 folds. That is how you test the model performance, the final model performance by averaging all the k folds. So certified k-fold cross-validation is simply k-fold validation, but with an added constraint of maintaining the same class distribution in each fold as in the entire dataset. This is particularly important for imbalanced datasets to ensure that each fold contains a representative sorry, sample of each class. Other cross-validation techniques include time series cross-validation, leave-one-out cross-validation, which is not efficient since you won't have the average of folds. And then there's the group K-fold cross-validation. So the other one is model selection and training. So we won't define all this since it's a repetition of something I've already defined, and we also have a look at it later on. So the popular algorithms of model selection and training is one is linear regression, logistic regression, decision trees, random forests, SVM, which is support vector machines, neural networks, and KNN, neighbors, gradient boosting machines, which said we won't really have a look at it, but all these other ones we'll have a look at them. And clustering algorithms like K-means and DB-score. So hyperparameter tuning. So there are a couple of methods of hyperparameter tuning. There's the Bayesian optimization. There's the grid search. There is the random search and other methods like PSO, which is particle swarm optimization and simulated annealing. But this is outdated. So model training best practices. So this is where you'll be guys know. So feature scaling, ensure that the input features are on the same scale, especially for algorithms sensitive to feature scales such as SVM and KNN, which we already stated a couple slides up. Then there's regularization, apply regularization techniques like lasso, ridge, or elastic net during model training to reduce overfitting and improve generalization. Then there's early stopping. So stop training when model performance on validation starts to degrade to prevent overfitting, which you can also do that using the lasso and ridge or elastic nets. Then the other one is data augmentation. Generate new training samples by applying random transformations to the existing data, especially useful for image-based tasks and small data sets. Then the last model training practice is model assembling. Combine multiple models to improve overall performance and reduce overfitting using techniques like bagging, boosting, or stacking. So a company like ChatGPT, I don't know if they use model assembling as a training method, which most likely they maybe use the boosting one, but the stacking whereby they use the 3.5 on top of 4, I don't really think that's really I don't think they really use that method, but I think I'll have to research more of that. So model validation and tuning. So performance evaluation. So there is AUC, confusion matrix, ROC curve. So this is finding the area under the receiving operating characteristics. Then other methods like classification or regression, precision, recall, F1 score, MSE, which is mean squared errors. So depending on the type of problem that you're handling. So I won't explain more on this, but as I've said, I'll draft something that is quite simple that doesn't contain all these mass. So, and we'll have do they call them glossaries or yeah, glossaries or glossaries, whereby I'll have a glossary defining every complex term, so you'll reference back to it. I think that's an easier method of learning. So model tuning techniques, so regularization, ensemble tools, which you've stated up here when I was discussing on the method that ChatGPT uses to better their models. And these hyperparameter tuning, we stated techniques like grid search, random search, and Bayesian optimization. So on the addressing overfitting and underfitting, overfitting, when a model captures noise in the training data and performs poorly on unseen data. To address overfitting, try using simpler models, adding regularization, reducing the number of features, increasing the amount of training data, or using techniques like the cross-validation. Then underfitting, when a model fails to capture the underlying structure of the data and performs poorly on both training and testing sets. To address underfitting, try using more complex methods. So I'll maybe let you guys brainstorm. Let's assume you're working for the DeepSeek. So which issue will you think is easy to handle? Either overfitting or underfitting. So in my opinion, I'd rather go with underfitting since this is a model that you've created that is working, but really needs more powerful methods. So for overfitting is your model is incapable of handling certain types of data, is performing poorly on certain types of data. Yeah, I'll let you brainstorm that and give yourself the answer. So to address underfitting, try using more complex models, adding more features or engineered features, or tuning hyperparameters to allow for greater algorithm flexibility. So that's addressing overfitting and underfitting issues. So model testing and evaluation. So final model evaluation on the test sets. So final model evaluation on the test set. So as we've said, the ratios of the data sets that you've given them, you divide them into like an 80-20 ratio. So when you are evaluating the uh, final model, these are the most used types of metrics and model selection. So after selecting the best model and tuning its hyperparameters, evaluate the final model on the previously held out test set to give to get an unbiased estimate of its performance on unseen data. So the way we've said, you give it 80-20% ratio, and you choose these data sets randomly so that it's not biased, so that you can see the full performance of your model. So use same performance method metrics such as accuracy, precision, recall, F1 score, and MSE as during the validation phase to maintain consistency and comparability. So interaction of results and conclusions. Analyze the model's performance on the test set to understand their strengths, weaknesses. Identify any potential biases or areas for improvement and determine whether the model meets the project goals. Consider the impact of the chosen performance metrics on the interpretation of the results, as different metrics may emphasize different aspects of the model's performance. Assess the practical implications of the model's performance, including its potential utility in real-world applications, the trade-offs between false positives and false negatives, and any ethical considerations or potential biasness in model predictions. Then, if the model does not meet the desired criteria, consider iterating on the machine learning process by revisiting steps such as feature engineering, model selection, or hyperparameter tuning for improved performance. And the last step, which I think is which is model deployment after you've tested the limits of your model. So you can deploy it from different platforms like Microsoft Azure, IBM Watson, Google Cloud AI platform, Amazon SageMaker. Yeah, all those platforms are for deploying the machine learning models. Create on the APIs, create custom API for your machine learning models to enable seamless integration with other applications and services. So you use frameworks like Fast API to generate seamless integration with other applications. So when another developer wants to use your machine learning model, so they'll just use the API that you've provided to integrate it into their own platform so that they can use your machine learning model. Then containers. So containers, when you hear containers, you just think of things like Docker and Kubernetes, which was a bit of a struggle during the time of campus. This was like one of the most complex things there back then, and it still is, in my opinion. But maybe some of you have encountered it, and it's a bit easier for you. But yeah, so package your models and their dependencies in containers using technologies like Docker or Kubernetes, with which provide a consistent and portable environment for model deployment, scaling, and management. So integration with web applications and other systems. So we have stated the framework that we use. So on Python, you use like Django or Flask. Then on JavaScript, you use React or Angular, or maybe, I don't know if they call it Vue or Vue. Yeah. those are the kind of frameworks that you integrate your machine learning models with when it comes to web applications. So on the backend system, connect your models to existing backend systems, databases, or data pipelines to automate tasks, generate insights, or inform decision-making processes. Integration can be accomplished through APIs and message queues, e.g., Kafka, RabbitMQ, or direct database connections. Then there's third-party services. I've got a bit of a few. That's why I keep on posting what I'm saying. So on third-party services, integrate your models with third-party services like chatbots, voice assistants, or IoT devices to expand the reach and capability of machine learning solutions. I think I had explained this on the instance that I saw on the VC Y Combinator. So yeah, some companies when you integrate they integrate their other companies' machine models to their platforms, the companies don't really want to fund such kind of ideas, which I think is a bit backward since they don't expect you to train a whole model and there's already existing data. So yeah. So the last part is model monitoring and maintenance. So monitoring model performance in production. So continuously track the performance of your models. Set up automated monitoring system to collect and analyze performance metrics such as accuracy and precision. Monitor other relevant factors such as latency, throughput, and resource utilizations. So latency is maybe like how fast does it give back data to the user. So that is latency. So updating and retraining models, regularly update and retrain your models using new data to maintain the effectiveness as the underlying data distributor or problem context changes over time. Then implement automated model retraining pipelines that periodically retrain your models with fresh data. Fine-tune hyperparameters and validate performances. Then the third one is establish a process for versioning and rolling back to previous models in case of performance degradation. But I don't think this is something that you should encounter after you've tested your model. But maybe in some instances, maybe you'll go back to the previous version since the current version is maybe not working. But that is not a common case. So the other one is model lifecycle management. So develop a systematic approach to manage your models through their entire life cycle. Implement model governance practices to ensure compliance with regulatory requirements such as ethical standards. And this is something that had eaten up Mistral since the EU, the European Union, had put on restrictions on artificial intelligence. That's why they were a bit behind. Since when you have a look at these large language models like ChatGPT, Kiwi, Quen, there are a lot. Okay, Mammoth is not a large language model, but when you have a look at it, you'll see that they are mainly in Northern America and Asia. But in Europe, Mistral is the first one. So things like implementing the model government practices is something that is taken very seriously. And the last point is foster collaboration among data scientists, engineers, or other stakeholders through version control systems, which is in this case Git, documentation and communication tools to streamline the model lifecycle management process. And in this case, I'll add up point one, like APIs. So in some cases, you'll find the documentation in some companies is quite horrible. So when, as a developer, you try to use an API from a certain company, it gets hard using it. So that's another thing. So you must put key. You must consider that heavily. Yeah, and I think that's the end of the introduction to machine learning. Is there any question? don't think there's any question. So uh, before even we finish this course, maybe you as a as a data scientist, you'll get to know on which field you want to focus more on. If it's on the neural networks, if it's on deep learning, if it's on machine learning. Yeah, you'll just get to know what is your liking as we proceed with the course. So if there is no question, I think we can join today's class. So yeah, I'll send you guys the summary of uh, this whole concept and have a glossary of the complex words of what they mean. And yeah, I think we'll have a good night with this. This is where the real world scenarios is coming to reflect from machine learning to deep learning to neural networks. Yeah, so such kind of things. So if there is no question or comment, um, you guys have a fantastic weekend. Let's meet on Monday. Um, so what I want you guys to do before Monday's session is install not install but okay, install Visual Studio Code, VS Code. I'll send you the link, and also get to know Streamlit, how you use it. It's an online IDE, not Streamlit but Replit, sorry. Then when we get to Streamlit, now we'll use Ether. I don't know. I'll see which one will be more user friendly between the VS Code, Visual Studio Code, or um uh, or Replit. So yeah, that is the assignment I'll give you guys. And one thing to note: don't download Visual Studio. Download Visual Studio Code. There's a difference between the two. So yeah, if there is nothing else, you guys have a fantastic weekend. Let's meet on Monday.